Okay, now let's take a look of the toy manufacturer's problem. Based on the problem descriptions, we notice that there's a fixed ordering cost and a holding cost. We also have a fixed demand rate as well as a fixed production rate. And because the production rate is not unlimited, so we cannot use EPQ model. Instead, we need to use EPQ model. So as usual, the first thing we want to do is to write down everything you know about the problem. So we have demand equal to 48,000. This is per year. And there are 240 working days. So you can actually find out what will be the daily demand as well. So we just use 48,000 divided by 240. We know the daily demand will be 200 per day. And the reason that we want to write down the daily demand is that later it will be easier for us for the calculations. We also know the production rate P. The production rate P is given us 800 per day. So we can convert this to the yearly productions. That will be 800 multiplied by 240. So it will be 192,000 per year. Okay. The holding cost will be $1 per year. And the fixed ordering cost will be $45. So we have everything we need for the EPQ model. We can start to solve the problem. And the first thing we want to do is to identify the optimal order quantities, the total production quantities that you want to produce for every inventory period. So we have the Q star. Based on the formulations for the EPQ, we know that's equal to 2 times AD divided by H, the holding cost, times 1 subtract by D divided by P. Okay, so let's plug in all the number. 2 times 45 times 48,000. Everything divided by H is 1. 1 subtract by D divided by P. So you can use 48,000 divided by 192,000, or you can use 200 divided by 800. They will be identical. So let's just use 48K divided by 192K. Okay? And based on my calculations, I know the optimal order quantity will be 4,800 units. Once you know the optimal quantity that you want to produce, the next thing we can do is to figure out the production period. And we know the production period, TP, will be equal to your optimal order quantity divided by your production rate. Why is that? If I know I'm going to produce 4,800 units, every day I'm going to produce 800. So this formulation can help you identify how many days it takes for you to produce 4,800. Okay? So you'll be 4,800 divided by 800, which is 6. And the unit will be days. And we know it takes 6 days for you to produce everything that will be needed for each inventory cycle. And we also know what you are producing, you are consuming the item you are producing at the same time. So we can calculate the maximum inventory you have, and we call it Qmax. What will be the formulation for Qmax? It will be TP, your total production time, multiplied by your net production for each unit time. So P subtract by D. Okay? So I have 6 days multiplied by 800 subtract by 200, because every day your inventory will increase by 600 units. So I know my maximum inventory will be 3600. Now we know the Qmax, we know the production period. The next thing we can do is to calculate the TD, the rate you are the time that it takes for you to run out of all the inventory. Okay, so I know my maximum inventory will be Qmax, and since you are not producing anything at Qmax, you are only consuming 200 each day. So I want to use Qmax divided by D. So 3600 divided by 200. I know it will take 18 days to run out of my inventory after the productions. So the total inventory cycle time, T will be equal to TP plus TD, which is 6 plus 18 equal to 24 days. I can also calculate what will be the optimal cost, and the formulation for the optimal Q and the corresponding cost will be square root of 2 times A times D times H, 1 subtract by D divided by P. Again, you just plug in all the number and you'll realize the total cost will be $3,600. So this answer every single question provided in the problem descriptions.